Meter plate, collector plate, source of light, micrometer, voltmeter, and commutator. So this is the glass tube. Here is the source of photons. It is the collector. It is the emitter. It is the collector. So light is emitted. Photons are photoelectrons are emitted, and we have a voltmeter. Then we have emitter. Then this is a variable rheostat which is used for changing the voltage, and this is the commutator for changing the polarity. So this is the construction of hallwach and lenard experiments. Now let's study the results. So the first result was that photocurrent is proportional to intensity. Graph is a straight line given that frequency is greater than threshold frequency. Next is, if we draw graph between current and voltage, it follows a graph like this, and on increasing voltage, current increases up to a certain limit where it becomes saturated, corresponded by I naught, and this saturation currents depends only on intensity of light or number of photons per unit time, whereas this point corresponds to the stopping potential. Next is, if we draw graph between intensity and voltage, keeping frequency same but number of photons or intensity different, then we get a graph like this. So we can say that intensity corresponding to third point is greater than that of second, greater than that of first. However, if we keep the intensity same but changes the frequency, then we get a graph like this, and corresponding to the largest magnitude of stopping potential, we have largest frequencies. So it follows the same order. Then again, if we draw graph between stopping potential and frequency, we get a curve like this. And it is an instantaneous effect, so it takes 10 is to power minus 9 second or less for the photoelectric effect. Now let's study the explanations. So it is that frequency is greater than threshold wavelength, threshold frequency or less than wavelength. Photocurrent increases with increasing voltage up to a certain limit where it becomes saturated, which depends only on intensity or number of photons but independent of the frequency. However, there is a clue in that, because intensity in general also depends on the frequency, but here the point is that change in frequency is less than 5%, so that we can assume that intensity is just dependent on the number of photons and neglecting the dependency on the frequency, as there is a very less relative change, so it's not gonna be more significant. Next is for a corresponding retarding potential, there is a photocurrent is zero, that we call as